Good day, everyone. I'm Dr. Provin Ajri Emmanuel from the Ghana Radio Astronomy Observatory, the Ghana Space Science and Technology Institute, and the Ghana Atomic Energy Commission. Today, I'm presenting on Galaxies, which is one of our series in the online astronomy and astrophysics. And also, we'll be touching base on Python programming for your kids. And it's going to be a wonderful session. So without much ado, I zoom into the picture on the screen is the Milky Way galaxy. And the Milky Way galaxy is actually, this is the most detailed map ever of the Milky Way galaxy, showing a catalog of 1.7 billion stars in the universe. Previously, scientists were thinking there was 600 million, and now this detailed picture shows that there's a lot more. And this is revolutionary because astronomers and astrophysicists can now use this map to study the galaxy like never before. And this picture or this data was taken by the telescope called the Gaia, which is an European Space Agency probe, which was launched in 2013 and now orbits the Sun, giving us all these detailed pictures of our universe. At the end of today's lesson, we will look at what galaxies are, how galaxies are classified, what is the fundamental ecosystems of these galaxies. I'll look at the Hubble Deep Field, that's the Hubble telescope being used to stare at a patch of the sky. And then I'll look at how galaxies exist in clusters, and then how they evolve or how they interact or how some eat up other ones. Then I will leave you with some stunning pictures of examples of galaxies. What is a galaxy? A galaxy is a group of billions of stars and their planets, the gas around them, the dust, that extends over many thousands of light years and forms a unit within the universe. Galaxies are held together by strong gravitational forces that bind the stars together, the gases around them, the other planets, and all the objects. Do you know that there are estimated 50 billions of galaxies in the universe? Think about it. A galaxy is a group of billions of stars. That's one unit. Then we have about 50 billion again of these smaller units in the universe. How are galaxies classified? Galaxies, you can't just look at them and say, okay, this one is this galaxy, or this one is far away and all that. Galaxies are were classified when one astronomer called Edwin Hubble in 1924 proved that galaxies are distant objects bound together by gravitational forces. He used what is called the Hubble tuning fork to classify these galaxies. Elliptical, spiral, and then also irregular galaxies. So this is one elliptical galaxy, IC2006. And then also we have the spherical galaxies, this is Messier 101. And then also the irregular galaxies, that's those that are neither elliptical nor irregular. This is an example, IC3583. Now, taking a look at the first one, which is the elliptical galaxy, the ones that are kind of ellipse, they are denoted by the letter E. They are subdivided again into E0 to E7. The E7 showing how flat they are, then the E0 showing how more round or circular they look like. Then also, there are subdivisions among them. Then looking at the spherical galaxy now, showing a central core, then the arms spiraling out of it. Then also we have another group within the spherical, which is called the SB, or you can see like something like a bar in between them. Now, this is also subdivided again. So I'll look at the first one, which is the S. It's subdivided again. This is a picture of our own Milky Way galaxy. you can see that the Milky Way galaxy actually have some kind of central bulge or central bar in there, because astronomers have been able to prove that there actually exists a central bar within within our Milky Way galaxy. Now look at where we are. The Earth is somewhere here. Then we have the rotating disk, which is spiraling. And then we have the spiral arms, as you can see, the dots, the yellow dots there. Now this is subdivided again into SA, SB, SC. The SA, how close they are to the central. The SC, how diverse they are from the central disk. Now, taking a look at the SB, which is the spherical and the bar, it's also subdivided again into SBA, SBB, then SBC. SBC being how diverse they are from the central. Then we come to the irregular galaxies. These are galaxies that are neither spherical nor elliptical. They just have some kind of weird look. Now, these irregular galaxies, you can just see that some of them look weird, some of them look beautiful, but you cannot tell from there whether this is far away, whether this is close by just looking at the picture. It depends on the distance they are, and then also the mass of the central system. That's what you'll be able to use to know. So coming back again to our Milky Way galaxy, you will see that the Milky Way galaxy is similar to other galaxies like the Purple galaxy, the Small Magellanic Cloud, and all that. And then this is the Large Magellanic Cloud, and this is the Small Magellanic Cloud. Galaxies are the fundamental ecosystems of the universe. And what are they? They are like cosmic engines that turn gas into stars, and then also turn the stars again back into gas. Between them, there are no star formation. Nothing happens in between the intergalactic space. They are recently discovered by Edwin Hubble in the late 1920s, as I just told you. They are classified by their shapes and then their sizes. So they are classified into three main groups: the ellipticals, that are galaxies that are pure bulge with no disk components, and the spirals, galaxies that contain varying amounts of disk components, from mostly bulge and barely detectable disks to those that are totally dominated by their disks. Then we have the irregular galaxies. These are very, very old galaxies that you can think of. Galaxies are grouped into some kind of clusters. They don't occur individually. They are in some kind of groups or friends. This is a picture of the Coma cluster, and then which is 300 million light years away from the Milky Way. And then it contains more than 1,000 smaller galaxies, or even up to 10,000 galaxies. The Milky Way, our Milky Way, is also a member of a local group of cluster, which contains about 40 galaxies. The largest member of the local group is M31, and then our Milky Way is the second in size within that local group. Galaxy evolution. Galaxies evolve with time. They interact with each other. Some even erupt or eat up other galaxies. Astronomers believe that the Milky Way galaxy actually evolved from some other galaxies. Now this, you can see, is a simulation of galaxies that are interacting, merging with each other, colliding with each other. But it's interesting to note that the stars in between them do not collide. It's just the shapes and everything that change around. This is also another beautiful picture of a galaxy merger happening over here. Then also you can see that this galaxy here is being erupted into the bigger one. This showing how galaxies evolve with time. So you can just see again how they collide, and then they form something else. Then after some, these are happening with in time scales of billions of years or billions of light years away. Now I want to show you the Hubble deep field. So just stay back. Listen.
Let's not be too hard on ourselves, though. I mean, of course the universe matters. It's just that the numbers in astronomy are too darn big to get our heads around. Our brains aren't wired to visualize big numbers like 78 billion. That's the size of the universe, 78 billion light years across. Saying that number, though, doesn't really help, does it? Luckily, an image was taken that can help us see just how big that number is at a glance.
So this is the Hubble telescope.
In 1995, the Hubble Space Telescope stared for 10 days at a rather unremarkable patch of sky. The results were nothing less than humbling on a universal scale. Thousands of galaxies filled the image. Roughly 3,000 galaxies were detected in a patch of sky that looks completely and utterly empty. Let's take a minute and put this in perspective. We live on a planet, one of 8 in our solar system. Miss you, Pluto. These planets orbit a rather unremarkable star. Our star is in a galaxy, one of 500,000 million in the Milky Way. I know, big numbers again, but bear with me. This is the Pinwheel Galaxy in the constellation Ursa Major, a galaxy much like our own. This is the largest and most detailed image of a spiral galaxy ever taken by the Hubble Space Telescope. Every one of these points of light is a star. Every single one. Some are bigger and some are smaller than our sun, but they're all stars. Many of them have planets orbiting around them. Looking at this image, the idea that the Earth may be the only planet in the entire universe that harbors life appears almost absurd. It seems much more likely that there are many more planets like ours. Our galaxy is just one of many in our local group. And there are many, many galaxies. When we look up at the sky, we can see only about 3,000 stars on a clear, dark night. From that, it's easy to think that that's all there is. The universe almost doesn't seem quite so big. Now we know better. The Hubble Deep Field is one of the few examples that help us get our heads around just how big our universe is. The story's not over, though. Later, in September 2003, the Hubble did it again. This time, it looked at another unremarkable section of sky and stared at it again for a little over 11 days. They used improved detectors with different filters, and this time, they saw this. This is called the Ultra Deep Field. It represents the farthest we've ever seen into the universe. Over 10,000 galaxies are in this picture. Every single dot, smudge, and smear is an entire galaxy. And each one of these dots has millions and millions of stars. Each star has the possibility of planets orbiting it, each one with the possibility of a civilization. This is what we see when we stare at a blank spot in the sky where nothing appears to be. This is the number of galaxies in nothing. This is a picture of 78 billion light years. It's a picture of how small we are. It is the single most important image ever taken by humanity.
This is the Hubble telescope that's launched in 1975. So now I leave you with stunning, beautiful images of galaxies. This is M8 M31, the Great Spiral Galaxy in Andromeda. It's a nearby galaxy in the local group of galaxies. This is the nuclear bulge of M31, taking a closer look at them and showing young stars that are formed. You can see the bright spots there that are young stars that are just formed within this M31. You can also see two satellites, Galaxies M32 and then NGC 205, which are both dwarf elliptical galaxies that are in the bottom, center, and then upper right of M31. This is the outer disk of M31. You can see showing much more galaxies out there. This is the central region of the spiral galaxy M51. You can see the central region showing very bright star-forming regions there. A lot of stars are being formed in this region right now. These are showing two barred spiral galaxies, M91 on the left, and then M109 on the right. You can see the bars across their nuclei showing the band of these galaxies. These are also some examples of elliptical galaxies. This is M32 and then M110. These are also another irregular galaxies. This is actually the irregular galaxy at the right. Is actually the Large Magellanic Cloud, and it is located about 180,000 light years away from the sun. And the bright headish feature in the upper right is another something called the Tarantula Nebula, and it's also a region of star formation within the Large Magellanic Cloud. This is dwarf irregular galaxy in Sagittarius, and this is, look at this beautiful picture of this disrupted galaxy called NGC 5128. These are active galaxies. They are actually referred to as Cepheid galaxies. This is NGC 7742, or otherwise called a normal spiral galaxy. This is M187. This is also an elliptical galaxy, and the jet that is seen is a great detail from the Hubble Space Telescope, showing a jet coming out of this galaxy. These are active galaxies. This is NGC 4139 and then Markarian 205. Thank you very much for watching.